Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on radioactivity. In the last lesson, you studied strong nuclear force, nuclear properties, and nuclear stability. You were also introduced to the term radioactive. Today, we will learn more about radioactivity, including radioactive emissions and decay. I am ready if you are, students. Let us begin the lesson. You have probably heard the term radioactivity, but you might not be sure exactly what it means. Radioactivity is the process by which an atomic nucleus of an unstable atom emits particles in order to reach a lower energy state and become more stable. This results in the nucleus splitting into two or more parts. In other words, an atom of one type, the parent nuclide, transforms into an atom of another type, called the daughter nuclide, and gives off an energy known as a radiation emission. When an atom loses this energy, the process is called radioactive decay. Radioactive decay is the spontaneous disintegration of a radioactive substance, along with the emission of ionizing radiation. Atoms decay without any interaction with another particle from outside the atom. According to quantum theory, it is impossible to predict when a given atom will decay. So, radioactive emissions occur randomly over space. However, when a large number of identical atoms decay, it is possible to predict an average decay rate. When a particle is emitted during nuclear decay, it leaves the nucleus with a certain amount of kinetic energy. As the particle travels, it ionizes other particles in its path and loses a small amount of kinetic energy with each interaction. Once it has lost all of its kinetic energy, it will stop and be absorbed by the substance it is contained in at that moment. The emissions that are given off during radioactive decay are commonly referred to as nuclear radiation. An electric or magnetic field can split these radioactive emissions into 3 different beams. Each beam has different properties. Students, the 3 most common types of nuclear radiation are alpha, beta, and gamma radiation. An alpha particle is relatively large with a positive charge of +2. It ionizes a great deal. A beta particle is a high-speed particle with a negative charge and little mass. It is much less ionizing than an alpha particle. A gamma ray has no charge and no mass. It is the least ionizing of the 3 emissions. Of the 3 types of radiation, students, which do you think is most harmful to humans? Use what you know about ionization and absorption to answer this question. Please write down your answers now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. This question was a little tricky. The answer depends on whether or not the radiation is outside of the body or is ingested into the body. Alpha ray emission that occurs outside of the body is not harmful because the alpha particles lose all of their energy before they can penetrate the skin. However, if alpha ray emission occurs inside the body, it will cause more damage than beta or gamma emissions. Students, you can find more information on exposure to radiation in the chart on page 332 of your textbook. As we learned, alpha particles ionize quickly, which means that they lose kinetic energy quickly. Alpha ray emissions can only travel a few centimeters in air before they are absorbed. They can be completely blocked by paper or skin. Beta particles are emitted when a neutron decays into a proton. They can travel much further than alpha particles because they do not lose their kinetic energy as quickly. It takes several meters of air or a thin sheet of aluminum to absorb beta emissions. Students, you probably recall gamma rays from their position in the electromagnetic spectrum. They are high frequency, high energy, electromagnetic radiation. As we have said, they have no charge and no mass, so they rarely interact with particles in their path. They are never truly absorbed, but their energy can be reduced to a point where they are considered to have been absorbed. It takes several centimeters of lead or several meters of concrete to reduce their energy. Because of their different penetrating powers, all radioactive sources must be handled with extreme care. When ionizing particles come into contact with human cells, they can cause radiation poisoning by killing the cells. They are also capable of mutating the cells so that they become cancerous. If radiation is so dangerous, why do you think it is purposely used in the medical field? Students, can you think of any medical uses for radiation? Please write down your thoughts and compare your answers with a classmate.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I wonder what answers you came up with. The most common use of radiation in medicine is using X-rays to see whether bones are broken. Phosphorescent materials sometimes include small quantities of radioactive atoms. During pharmaceutical testing, drugs are sometimes laced with radioactive atoms so that they can be more easily traced as they move throughout the body. Radiation can be used to sterilize medical instruments because it kills microorganisms that cause contamination and disease. Although we know that radiation can cause cancer, it is also often used to treat cancer. A beam of radiation can be used to treat affected areas by killing the malignant cells. Before scientists realized how dangerous radiation was, radioactive material used to be used in luminescent paint for a glow-in-the-dark effect on watches and clocks. Students, have you ever seen the hands on a watch glow in the dark? This effect is achieved by a combination of radium and zinc sulfide. As the radioactive particles emitted by the radium strike the zinc, they produce a faint light. Today, most manufacturers use tritium instead of radium to achieve luminescence because tritium emits only low-energy beta particles. This type of radiation is unable to penetrate the glass of the watch or clock. Students, it is very important for scientists and medical professionals to monitor levels of radiation. They use instruments called ionization detectors to track the levels of ionizing radiation. The most well-known of these detectors is the Geiger counter. You may want to do further research on how a Geiger counter works. It is very interesting. Today, we have learned how radioactive decay produces radiation. We have studied the nature of 3 kinds of radiation emissions and can describe their relative ionizing effects. We have also learned some ways that radiation can be beneficial. Until next time, thank you, teacher. Thank you, students.